Raise your hand if you took econ first semester. Okay, so a couple people, raise your hand if you're taking econ right now. Okay. Just because you're going to see some pieces if you took econ first semester that you're going to be like, oh, that's what we were talking about. I never knew why. Well, we're going to prove it today, and you're going to just have a nice little introduction. This is not going to be on your AP exam. Why are we covering it? It's required by Riverland that we cover applications to economics. We spend 1 day on it. We put a little bit on tests. That's it. It's not going to be challenging. You ready? Cost function is C of X. We've done this before. If it cost me $200 to make 20 pairs of shoes, what was the average cost? Try again. It cost me $200 to make 20 pairs of shoes. What was the average cost? 10. Yeah. No, your total cost is 200. Cost me $200 total to make 10 pair of shoes. Point out. Okay. So if you want the average cost function, you take the entire cost and you divide that entire cost by the number of items you produced. How many items are we producing? X number of items. So the average cost function in terms of X, or number of items we're producing, is C of X divided by X. Now, first semester we talked about the marginal cost function. The marginal cost function was simply C prime of X. And this will help you remember what the marginal cost function meant. It said if we're a shoe factory, we're making shoes, we've made 500 of them, I want to know what would be the approximate cost of producing the 500 first set of shoes. Do you think it costs more to produce the first set or produce the 500 first set? To produce 501 shoes costs in total more than it does to produce one, right? That makes sense. However, what do you think costs less? To just produce one or to produce the 500 first after we've already produced 500? Why? You're more efficient, right? Everything's set up. Got it? So we said that C prime of X was really the approximate cost of producing the next item. So what we want to do in economics a lot of times, we want to minimize cost, minimize average cost. You're going to get all these formulas on the test, okay? You just got to know where to grab them, where to use them. So let's show how to generate minimal cost. We're going to use calculus in order to do that. So again, what are the applications of calculus? You're sitting in economics and you don't even know you're using the calculus. They just give you the formulas. The only reason they had them is because calculus was invented. So here's what we're going to do. We're going to take a prime of x. If we want to minimize something, we take the derivative and we set it equal to 0. In order to take the derivative of average cost, what rule do I have to use? Quotient rule, right? What's the derivative of the top? C prime of x times the bottom left alone, x, minus derivative of the bottom is 1 times C of x. Yep, I know what you guys are saying. You're absolutely right. Divided by x squared. Okay. We take the derivative and we set it equal to, because we're trying to minimize the average cost. So derivative set equal to 0, I'll write over 1 is equal to x C prime of x, I'll write the x in front, minus C of x, all over x squared. Now, I could do two things. I could cross multiply, or I could just say if the top is equal to 0, then the whole thing's equal to 0, right? Either way you want to think about it is fine. I'll just, cross multiply, get 0 is equal to x times C prime of x minus C of x. Now, we're technically really kind of done here. but we're going to put it into a form that we can understand. Because what does C of x represent? Cost. What does C prime of x represent? Marginal cost. X represents the number of items we've produced. So I'm going to just kind of gather some terms and see if I can turn it into something that looks more familiar to what we have. So now I have a positive cost function, and I have x times C prime of x. Does anybody see one last thing I can do to make it look like two formulas that we have up there? Divide by x. Thank you, Karina. I'm going to divide by x, and I have C of x divided by x is equal to C prime of x. Those are two formulas we had from up above, right? What is C of x over x? That's your average cost function. What is C prime of x? Marginal. So here's what we just did with calculus. We just proved that the minimal average cost happens when the average cost function is equal to the marginal cost function. So who took econ again for semester? Do you remember that formula coming up? Okay, it happened, I think. I don't know. Somebody from second hour said that they remember that idea or that statement. They maybe didn't remember they didn't maybe see this part, but they saw this apparently. Okay, maybe that. All right. So if we want to minimize average cost, we take C prime of x, and we set it equal to C of x over x. And if you wonder why that's what we do, then you have to look back at our proof. We just used a derivative, the quotient rule, and we made it look like something that we know. Okay, so we'll flip it over. We can quick at least set this up, and then we'll get to lunch. We will. We're going to do the maximum profit here in a little bit, but first let's just do example 2. The cost of producing x items is C of x is equal to 2,600 plus 2x plus 0.001 x squared. Find the cost of producing 1,000 items. How do I do that? Yeah, I plug in 1,000. So I'm just making sure that you understand the difference between all the different functions. So 2,600 plus 2 times 1,000 plus 0.001 times 1,000 squared. We'll do that when you guys get back, okay? And that's where we'll pick up, and then we'll do the maximum profit, okay? So we'll calculate that when we get back. So we'll get some brain food, come back smart. All right, here we go. So you got to calculate this. You plug in 1,000, and anybody got the value? Plug in 1,000. Very good. So we got 5,600. So it says, what's the cost? We'll say $5,600. It could be in millions. It could be in billions. Who knows? Okay. It says the cost, average cost for producing 1,000 items. How do you calculate average cost? Yes, take the cost of X items and divide it by X, or the cost of 1,000 items divided by 1,000 items, which is the same as 5,600 divided by 1,000, which is $5.60. Marginal cost producing 1,000 items. How do I do that? Derivative. So C prime of x is equal to derivative of 2,600 plus 2x plus that is 2 plus 0.002x. I'm going to plug in 1,000, and I get 2 plus, I took the derivative. So I drop that 2 down in front. And when I take 2 thousandths times 1,000, I get 2. Get $4. Somebody who's really smart, speak up and tell me, what does that $4 mean? The cost of producing the 1,000 first item will be approximately $4. Exactly. Okay, good job. Now, let's think about this. Yeah, the 1,000 first item will be approximately $4 to produce. Now, consider these two pieces. Hi there. The cost of producing 1,000 items, average, think about this. Does it make sense that the average cost of producing 1,000 items is higher than the cost of producing the 1,000 first item? Why? Somebody explain it to me. Become more smart. Okay, become more efficient. Okay, so the cost at the very beginning might have been like, say, $15 an item, then 10, then 8, then whatever, right? And that will affect the average. It will make the average higher, but we'll be better at that point, right? Okay, good point. Excellent. So, finally, the production level, that will minimize the average cost. If I want to minimize the average cost, I take the marginal cost function and set it equal to the average cost function. Somebody tell me we are going to do this. What is C prime of x? No. That's C prime of 1,000. C prime of x. 2 plus 0.002x. Good. Equals, what is C of x? No, that's C of 1,000. What's 2,600? This is how you know it. Divided by x. So this is how we minimize average cost. We set the marginal cost function, or the derivative, equal to the average cost function. How do we solve something like that? Let's multiply. Good. 2x plus 0.002x squared is equal to 2,600 plus 2x plus 0.001x squared. What do you get rid of? 2x is gone. Boom. Add my 0.001x squared over to the other side. I get or subtracted over, excuse me, is equal to 2,600. Add both sides by 0.001, and I get x squared is equal to 2,600,000. Now what? Square root of both sides. So let me take the square root of 2,600,000. Okay, now this is not referring to dollars, but to number of items. Yes, the product. So it looks like it would be most efficient to make 1,612 items, right in that ballpark. Once they start producing more or less, the average cost will go up. We don't really know in context of the problem. So you're absolutely right that, as they give you this cost function, maybe that's over the course of a day, maybe it's over the course of a week. I'm not sure, but yes. So this is C prime of x. So I took the derivative of that. Got it? Any other questions? Okay, then we turn back to the very beginning, because economics is not just interested about cost, but really revenue and profit. And so we have something that we call a price function. We'll call it P of x. The reason why we call price a function is because the price goes up and down. What's one thing that we purchase usually weekly or monthly that price changes? Gas. Yeah, right now I filled up at Hy-Vee yesterday, I think $1.56 a gallon. I didn't think I would ever live to see gas that low again. I really didn't. I just can't believe we would get there. But I mean, who knows where the end is at this point? But when I was in when I just got married, I remember that gas was sitting at $1.89 a gallon. And I paid that for a couple years. It was shortly after that that gas increased to $2. There was a not too long after that. I remember where it blew up all the way to 3.96 a gallon. Anybody remember those days? That was horrible. Yeah, and then last year, it all of a sudden, or this summer, it started to dip back around like 250, and I was like, I can handle 250. And then it was at two, and now it's at basically 150. You get a coupon for 4 cents off a gallon or something. You're sitting pretty good. So price is a function, and tell me, as the demand increases, what will happen to the price? It will increase as well, right? If the supply increases, what will happen to the price? It will go down. So supply and demand are inversely related, and price and supply are inversely related. But demand and price are directly related. So price function changes. Now, if this is the price function, we have revenue. Revenue happens as you charge a certain amount for a product and then you sell a certain number of items of that product. So revenue is actually equal to the price per product item times the number of products you sell. Does that make sense? If I am charging $2 for gasoline a gallon and I purchase 10 gallons, I will have a revenue of $20. Okay? So that's why we get XP of X. So we have a marginal revenue function, which is R prime of X. So now we've come up with revenue function. Just like we have marginal cost function up here, we have a marginal revenue function, which is simply the derivative. And we have a profit function, P of X. Can somebody tell me how do we calculate P of X now that we know revenue and we know cost? Close. R of X. Use your cost function. We will subtract C of X, right? If I have a revenue, like last night I was at concessions, we brought in $1,500, okay? Our expense was probably around about $1,100, in terms of product that we purchased, okay? So that means our profit was $400. We simply just subtract the two, okay? So if we want to know the marginal profit function, we simply take the derivative. You guys know as well as I do that in economics and in business, we would like to maximize profit. So in order to maximize profit, what do I do to the profit function? I take the derivative. Now, the profit function is R of X minus C of X. Now remember our rules with derivatives, when you have subtraction, you just take the derivative of each one, right? So we have R prime of X minus C prime of X. If we want to maximize it, we set the derivative equal to 0, and we get R prime of X minus C prime of X. Again, we would like to write an equation that expresses these in a unique way, and we get C prime of X is equal to R prime of X. So the maximum profit occurs when C prime of X is equal to R prime of X. When that happens, we get maximum profit. You see how we generated the formula? Okay, it's not that tough, was it? Okay, and it makes sense. So let's apply it, and then you can have your assignment. It says, given a company has a cost function of that and a price function of that, find A, the maximum profit for the company, and B, the production level at which the marginal cost begins to increase. We won't focus on B right now, but maximum profit we will consider. We have a cost function. And it's that thing right up there. I'm not going to write all of it down. It's a lot of work. But in order to come up with a profit function, I also need to know revenue function, correct? Revenue function is going to be x times p of x. Which is equal to what? What is x times p of x? Yep, so 3.5x minus 0.01x squared. I now have a revenue function and I have a cost function. Yeah, so revenue is equal to x times p of x. And if I take x and I multiply p of x, oh yes, I'm sorry, there's supposed to be an equal sign there. Sorry about that. Sorry. So when you distribute the x through, you get 3.5x, so you get 0.01x squared. Correct? All right. So if we want to maximize profit, we take the marginal revenue function and set it equal to the marginal cost function. Or the derivative of one equals to the derivative of the other. What's the derivative of r of x? Good. Equals, I took the derivative of the revenue function. Yep, r prime of x equals c prime of x. I'll write that down. What is c prime of x? See, there's 4 zeros. If I multiply the 7 by 3, I'm going to put 3 zeros. Okay, what happens? Those go away. That's nifty. If I subtract 1.26 over, I get 2.24. Okay. Ask me if you want. Equals 0.00021 x squared. I have to take the square root of that. 103.28 items. So 103.28 items is what we need to produce in order to maximize the profit. If we produce more, we'll end up spending more money than we're bringing in. 103 would be fine, or 104 would be fine, or 103.28 would be fine. Okay, I think we know how to round, right? So if you're in the context in an economics class, they ask you one or the other, then you go ahead and do that. It does not answer the question. So the question is, find the maximum profit. So this tells me the number of items. What do I then have to do? Plug it into the revenue function minus the cost function. So we gotta plug all that in. It's gonna take a little while, but at least this will kind of tell us what our result is. So we got parentheses 3.5 times 103.28 minus parentheses 0.01. Oh, I don't need 0.01 parentheses times 103.28 squared. So right now I have That's revenue of 103.28 that I've typed in. And then I subtract the cost function. So I'll now plug in the cost function. No, this is just R of X. So remember that our formula for profit, P of X, is equal to R of X minus C of X. Yep, so I'm taking R of 103.28. So I'm plugging that in right here. And now I'm going to subtract C of 103.28. So parentheses, 84 plus 1.26 times 103.28 minus 0.01 times 103.28 squared plus 0.1234 times 103.28 raised to the third and parenthesis 70.23. Now that might be in thousands, that might be in millions, it might be in billions, who knows? But we'll just list it as 70.23 that's maximum. Doesn't sound like very much money, but like I said, it could be in hundreds, could be in thousands, could be in whatever they're estimating. Right. We don't have time for B. We'll have to just quick do that on Monday. Won't take too long. But what we will do is we will look at an assignment. And 5 through 7, 11 through 13, 15 and 16 is what we will cover Monday. And then, again, the rest of the day Monday and all day Tuesday, you'll have his work days. You have your study guide in hand. This assignment should not take you very long to get through. And then we have a test on Wednesday. It is entirely possible. Well, I'll shut this off.